Okay guys, I hope you attempted this example on your own. If not, sorry, I'm not talking through the whole thing, but I got common denominators first. Then I added across the top. I saw the cosine squared and the sine squared, so that made me remember my identity. Okay, so I switched out the cosine squared, sine squared with 1, and then I brought down the plus 1 plus 2 sine x. I combined like terms in my numerator. Then I saw my 2 plus 2 sine x and realized, oh, I can take out a 2, which then gave me 2 times 1 plus sine of x over cosine of x times 1 plus sine. Was now able to eliminate those 1 plus sines, which left me 2 over cosine. 1 over cosine is secant, so 2 over cosine would be 2 secant. Okay. If you need any additional help with the adding and subtracting, just let me know. My one caution to you on a subtraction problem, and I'll erase this here in just a second. If this had been a minus sign, make sure you turn it into a positive and switch the signs of the numerator. That way you get your positives and negatives in the right place, okay? Now, for the division problems, and division is maybe not the best choice of header for this because it's really not truly division, but what we're gonna do for these type of problems, and this will be the last section that's on your homework as well, we're going to use conjugates. In order to simplify. What is a conjugate if you don't remember? If I have 1 plus cosine of x, the conjugate would be 1 minus cosine of x. That way when we distribute, the middle terms will cancel and things will simplify or turn into identities, okay? So for this first example, I'm gonna first use the conjugate to see if I can get some things to simplify and cancel. So the conjugate of 1 plus sine would be 1 minus sine. I distribute. And I'm going to distribute the denominator. 1 times 1. Okay. Now, I've got a negative sign and a positive sign in my denominator. Those are going to cancel each other out. And I know it seems like nothing's happening yet. However, I have an identity that has a sine squared and a 1 in it. Hey, we've used this one quite a bit. There's an identity that says cosine squared plus sine squared equals 1. Can I, and should I, manipulate this identity to make it match what's in my denominator? My denominator says 1 minus sine squared. So if I look at my identity that I wrote over here, if I subtract sine squared over to the other side, I get 1 minus sine squared is equal to cosine squared. So I'm going to replace 1 minus sine squared with what it equals of cosine squared. All right. So now, and again, I'm trying to, this lesson I can kind of give you some like, do exactly this, because this is not a lot of identity work. This is just algebra manipulation. I can separate a fraction by taking 1 minus cosine squared x minus sine over cosine squared x. Okay, that's a legal move to do. Here's why. Okay, just watch and if I have 3 plus 7, nope, I don't want to do that way. 3/4 plus 2/4. We add fractions by adding the numerators together and keeping the denominator. So what I'm doing here is I'm just doing the reverse effect. I'm separating back out those two fractions, okay? And if it still throws you off a little bit because I put numbers, what if I made this 2 an x? I can add the fraction, and my numerator would say 3 plus x over 4. Well, that can go in either direction. I could separate it back out into the two separate fractions, or I can leave it condensed. But since we're ultimately wanting to simplify, I'm separating them out because now I have 1 over cosine squared. Well, there's an identity that 1 over cosine is equal to secant. So 1 over cosine squared would be equal to secant squared. Minus. Now this piece is a little trickier. I've got, if this had been sine squared over cosine squared, easy peasy. But since they're not the same size, I've got to think a little harder, okay? So can I rewrite this as sine over cosine cosine? Because that's what cosine squared means. Now look. We have an identity for sine over cosine. Sine over cosine is equal to tangent. We also have an identity for, because I can put a 1 there, 1 over cosine. Oh, I already have that written down. Good. We said that that's secant. So, sine over cosine is tangent. 1 over cosine is secant. And then I have my minus secant squared at the front. Okay. Let's work another one. We're going to use conjugates again. So my denominator is 1 minus cosine, so my conjugate would be 1 plus cosine. And I'm foiling, distributing, whichever terminology you like best. Okay. Sorry, I switched colors midway through. So in my denominator, I have a positive and negative cosine, so those cancel. All right, my denominator. Yeah, I've got some sine squareds and stuff going on in the numerator, but I'm gonna pause and wait for that. Let's clean up this denominator first. I have an identity that says cosine squared plus sine squared equals 1. This time, if I subtract the cosine squared over, I would have sine squared equals 1 minus cosine squared. Now that matches what I need. So my numerator is still the same. I can replace 1 minus cosine squared with sine squared. All right, I realize that looks uglier than what it started, but now I see something. I'm going to go back to my numerator and I'm going to undistribute. I'm going to pull the sine squared back out so that this says sine squared times 1 plus cosine. I'm kind of backpedaling a little bit, I realize. The reason why I wanted to do that is because now, by factoring that sine squared out, I can cancel a sine squared in both the numerator and the denominator, leaving me with 1 plus cosine of x. Okay, so the division problems are not truly division. It's just a bunch of, can you multiply by conjugate and then algebra manipulations to get to identities. Same as always. Oh, excuse me. If you get stuck, please